In this video, I'd like to introduce the concept of dividing polynomials. And specifically, we're going to start by just dividing by x, where we're not going to end up with some remainder. And in later videos, we will see more complicated examples. Now, for a problem like this, so we have 2x cubed minus 5x squared plus x, we're going to divide everything by x. Now, the key idea is that x is going to divide into every term in the numerator. Now, one common mistake students make is they'll just pick one of these, maybe the first one, maybe the last one, and they'll divide and say that this is falsely equal to 2x squared minus 5x squared plus x, and then keep simplifying. But the key idea here, like I mentioned, is that x is going to divide into all three of these terms. So one thing you can do is separate them into their individual fractions. So 2x cubed divided by x, let's just write that. And then we have minus 5x squared divided by x, and then plus x divided by x. And this way, each term from this polynomial in the numerator is divided by x. And from here, it's easier to see how it simplifies. We have 2x cubed divided by x, so x cubed, there's three of them up top, and we're dividing by one of them down below, and so one will cancel out, and you get 2x squared. Then from this one, you have x squared divided by x, 2 up top, 1 down below. You'd be able to cancel out 1 and be left with 5x. Because remember, when dividing by x, let's say for this first one, x cubed is just x times x times x, and we're dividing by x. Now, since this is a product, this is different than adding and subtracting. Since this is all just one term, you have x divided by x, and this will cancel out. You can, in this case, just pick one of them to divide into because you have multiplication, because all of these are one term rather than separate terms added or subtracted together. So in this case, you get x squared. And you can see that with numbers. If you want to put in numbers instead of variables, like if you had 4 cubed over 4, this would be 4 times 4 times 4 divided by 4. And so that's 64 divided by 4, which is 16, or 4 squared. You'd be left with just 2 of them. So those would cancel out. But if you're dealing with adding and subtracting, it's a little bit different. So if you had, let's say, 4 squared plus 3 squared, something like that, and divide this by 4, now we can't just pick and choose. We can't just say that one of the 4's cancels here and you have 3 squared. This is not true. And you can verify that with numbers, because this is 16 plus 9 over 4, so that's 25 over 4. But this answer would be 4 plus 9, which is 13. And you can see 25 fourths, which would be 6 and 1/4, if we divided that and put it as a mixed number, is not equal to 13. So you can't just make this division when you have addition, but just to show you one further idea, if we had 4 times 4 times 3 times 3 divided by 4, this would work. We could divide 4 divided by 4 and kind of ignore the 3's because they're all multiplied. It's all one term. And so here you'd be left with 4 times 9, which is 36. But you can also see that the original problem, this 4 times 4 times 3 times 3, so that would be in the numerator 16 times 9, which is 144. And 144 divided by 4, well, 4 goes into 14 3 whole times, there's 2 left over, and 4 goes into 24 6 times. So you can see with numbers that it does work. When you have this multiplication, you can just pick and choose. But when you have addition, you can't do this. You'll create 2 answers that are not equal to each other anymore. So when they're separated with adding and subtracting, then this 4 has to divide into everything. So you could write it as 4 squared over 4, plus 3 squared over 4. And this would be true because now the 4 is going into both, but this one was not true because here you just picked and chose that the 4 only went into one term when it really needs to go into both. So that's kind of the general idea. When you have multiplication, you can cancel out by just choosing which it divides into. But when you have addition and subtraction, it has to divide into all three of those. So just to finish the problem, since that was a bit of a detour, we had this minus 5x squared divided by x, so one of the x's canceled. We were left with minus 5x. And then x divided by x is just 1. So our final answer here, when we do divide these polynomials, since technically x by itself is a polynomial, it's just a first degree polynomial with one term, we end up with this quadratic expression, because in these we're not going to end up with remainders where you'll have some kind of fractional term at the end. So let's do some more of these just to get some practice. So we can rewrite this as a fifth degree polynomial up top, 2x to the fifth plus 5x cubed divided by, again, a 1 degree polynomial, x. And this x will divide into both of these. So we can write it out as different fractions, 2x to the fifth divided by x. And then for the second term in our numerator, we have 5x cubed divided by x. And so we have 5 x's up top and 1 below. And so 1 will cancel, and we're left with x to the fourth. And with this one, you have the 5 and x cubed. You have 3 up top and 1 down below. So 1 again will cancel, and you're left with x squared. Now you could remember the rule. If you have, let's say, x to the seventh over x to the third, that when you're dividing and they have the same base and different exponents, that you're really just subtracting and you get x to the fourth. But you do want to understand that where you have 7 of them up top multiplied together and 1 down or 3 down below, and so 3 of them are going to be able to cancel out and you're left with 4 of them. So this right here will be our final answer, which we'll put in the box. And we can do another problem. So you don't have to write it out as these two different fractions every time, since the x is going into both of these. But when you're first learning this, this is probably a good habit, just to understand what is really going on and that the x goes into both. But really, we're just going to be reducing each of these exponents from our x terms in the numerator by 1, because we're dividing each of them by 1x. So for here, x cubed divided by x would be x squared. And the 4 just carries along. The numbers are just going to move along because we're not dividing by like 2x or anything like that. So here we have x squared divided by x, which is just x. One of them will cancel out. So in the box, we can put 4x squared plus x. And let's do one final question. So 3x to the fourth. That will be divided by x. Then we have the minus 6x squared divided by x, and then minus x divided by x. So this, the x will be reduced by 1. We get 3x cubed. This one becomes x squared reduced by 1, so that's just x, so 6x. And x divided by x we know is 1, so we get negative 1 there. So this 3x cubed minus 6x minus 1 would be our final answer.